Okay, so this first one we're just gonna go through unit 1 and 2. Okay, so this first unit was on your atomic theory and isotopes. So we're gonna go through this little timeline. Remember who's who and what their model was, and either what experiment they did or whatever they got. Okay, so for the first one, there you go. All right, for this first one, what model is this? Plum pudding, good. Okay, and who came up with plum pudding, or who remembers what the experiment was? It was J.J. Thomson, and it was your cathode ray tube. You do not need to know that, but if it helps you remember, he's the one who was like bending the little light things up and down and stuff like that, okay? So J.J. Thomson, plum pudding model. Okay, next one. We got cloud model. Okay, and who came up with that one? Schrodinger, good. Okay, good. And this one right here, this is today's, right? So that's what our model is today that we use. Okay. All right, next we've got, which one is this one? This should be easy. This is Bohr, and I'm going to put planetary in little parentheses there because it was planetary or solar system. Okay, so that was obviously made by Bohr, and we found out it was oversimplified, and it only worked for actually our first two elements. And then I'm going to add in one more. So I want you to put a big dot right there. Who remembers what the big dot one was? What was it? Billiard ball. And who came up with it? The weird dude? That's harsh. It's Dalton. All right, so one thing that you should look through tonight, I'm not going to go through them, are his postulates. You guys have them listed, and we also pointed out which ones did he find were not true. And it had to do with things having the same mass, as well as whether the atom was the smallest particle there is, okay? And then finally, letter Z is talking about who? Or which one? It's Rutherford. So you guys, yeah. Nobody ever remembers this one. It's the nuclear model. Am I still on the screen? Okay, cool. All right, there you go. I wasn't on my screen, sorry. All right, so this is your nuclear model. Okay. Can you guys see it? You're good? Okay. Okay, cool. All right, so real quick, let's put them in order before we move on. So which one came first? Billiard ball. Good. Which one came second? Plum pudding. Which one came third? Nuclear. Which one came fourth? And then this one. Okay. And who was the guy who came up with the neutrons or found the neutrons? Chadwick.
Wait, Chadwick was
Neutrons. All right. You don't have to know that one. Poor guy. Like, I always feel bad for him. Like, we'll just put his name on there, and because Chadwick is about the next one. There we go. All right. Okay. Okay. So one thing that I am going to have you do is turn your paper sideways, because we're going to remind ourselves of two definitions. So you're going to write them kind of side by side, so don't write too big, okay? But I want you to write down ions, okay? You're writing it kind of on the side of your paper. You have a little gap right there. You're not going to write very much. Ions are things that have the same atomic number, which is what? Number of protons, okay? But they have different neutrons. Good. No, not neutrons, I'm sorry. Electrons, I totally zoned out there. Different electrons. So you have like positively charged things, you have negatively charged things.
So what is the, does that just mean that's positive?
Huh?
That's what it says. Yeah.
Yeah, that's protons. Okay. Your isotopes, now you can say the neutron thing. Okay. So your isotopes have, again, the same atomic number, okay, which is your number of protons again, but they have different masses, so they have different neutrons. Okay, so remember, the next calculation we're about to do is we're coming up with that average atomic mass using the isotopes. So all those numbers that are up there on that periodic table are weighted averages, just like your grades are. So some of your grade is 40% is tests and labs and 20% is your daily stuff, right? So same thing here. So we're going to do that next. Turn your packet back normal. Let's go ahead and look at this. So this one is saying Mendeleev ordered the periodic table according to atomic mass. Chlorine has 2 isotopes. Calculate the average atomic mass. So I'm going to write down the steps for you, and then you are going to do it, okay? So, and then we'll look at the answer after. All right, so remember your steps are, okay, yep, we move that decimal to the left on which number? The percentage. Good, your relative abundance. You're right, you're right. Okay. Then we, good, multiply, I'm going to say across for this one, but you're multiplying by mass. Okay, and then your last step is, not moving decimals anymore, we're adding them up. Okay? No, yeah. I don't know. Hold on. All right. So what I'm going to have you guys do is go ahead and use those steps, calculate it. We're going to check back in 1 minute, okay? Okay, so you should have started with your decimal moved over to the left. You multiplied across. You got the values that are right here. And then you added those guys up to get your 35.44. And we just went to 2 after the decimal place. And what's the units on this? AMU, that's awesome. AMU, yeah. Good. Okay. All right. Any questions? Awesome. Moving on. So, this part is talking about Rutherford's model, or his experiment. So what I would do, just so you can kind of know it's there when you go back to study this later, I would draw a little arrow from Rutherford down to this so that you know if you need help on that later. You can look at that, okay? Okay, so this says he devised an experiment to probe the structure of the atom, which is correct. So we're going to go through this. We are going to go through all the answers and X out the stuff that is incorrect, okay? So, so for number 1, the reflected alpha particles bounced off a positively charged nucleus, which proved the existence of the nucleus. How does that sound? Did he prove the existence of the nucleus? No. His model is called the nuclear model. Did he prove the existence of the nucleus? All right. Good. That was the right answer. Good job. All right. Okay. So number 2, the reflected alpha particles bounced off of the atoms in the gold foil, which proved the existence of atoms. No. No, that's weird. All right. Number 3, most of the alpha particles went straight through, which proved that atoms are neutral. No. That wasn't the big thing here. Okay. All right, and then most of the alpha particles went straight through the gold foil undeflected, which proved the positive charge was spread out evenly. What? No way. All right, so the best one is number 1 up there, okay? Any questions? So it is nuclear model. All right, go ahead and, oh no, you guys are on the same page. I'm going to turn the page. All right, here we go. So number 4, okay, is saying, using the table to the right, answer the questions below. So this question I kind of put together to make sure you're covering also stuff that we just did, Okay? So remember your primary difference between ions and isotopes, right? Ions are a change in what? Electrons. Isotopes are a change in neutrons. Good. All right. So before we even start answering any of these, okay? Protons are the same as your what number? This is your atomic number. Okay? Okay, looking here, do we have any ions? Do you have any charged particles? Z, right? So this guy makes it an ion. The fact that it is not equal to my number of protons. Okay? And then, so judging off of our electrically neutral things, so things that have the same protons and electrons, so these guys right here, what are those guys called because of these two numbers? These are your isotope, or sorry, X and Y are going to be your isotopes, okay? All right, so now we're ready to look at these. So this first question says, what element is X, Y, and Z? Fluorine, how'd you know that? Your atomic number, good. So atomic number 9. So this was fluorine, good. Next question, is particle Z an ion, isotope, or electrically neutral? Ion. Which two particles are isotopes? X and Y. Okay, and we're talking about neutral things here. Okay. Technically, the other guy is too. All right. What is the electron configuration of particle X? All right, so go ahead and you guys try it. Write it on your paper first, then we'll check on mine. Okay. Okay. So, did you get 1s2, 2s2, 2p5? Yes. Awesome. That's good. Okay. So the next question is, we're going to go through what the words are again. So period is what? The up, down, or the horizontal? Horizontal. Good. So we're going to put a little arrow like that. What's sublevel mean?
The same.
Yep. Yeah. Good. So S, P, D, F. She said save the planet for real. Oh, well, don't forget it. Don't forget it. Oh. Group number, so those guys are the up, downs, and then we're going to do our family name, okay? So particle Y, well, they're all fluorine. So let's go ahead and look at that. What period is fluorine in? 2. He's in 2. Okay, what sublevel? P. What group number? 17. If you said 7, please don't do that. Okay, 7 is talking about the main groups. All right, and then family name. Halogens, good. Sorry, on my iPad, I'm actually like off the screen right there. That's why I had to go up. Okay, all right. Does particle X or Z have a greater atomic radius and why? Good, all right, so I've kind of heard it a couple times now. Z. Z is your ion. Okay, is it a cation or an anion? Anion. Anions get bigger because they have more electrons, right? So more electrons means more repelling, which means big. Okay? So particle Z, so your ions. If we were talking about something that maybe if it had 8 electrons, so it was a cation, what would you have answered? Would you have answered for the cation or the neutral one? The neutral one, good, okay. Cations give it away, they shrink it, they shrink up, okay. All right, is particle Y more or less electronegative than magnesium? Doesn't sound very confident. So real quick, is electronegative talking about your radius or is it talking about the heart trend? This is the heart trend. Good. So like ionization energy. So remember, the heart trend is little heart, huge heart. Okay? Good. So more. Okay? I'm going to add one more piece to this little question. I want us to answer the same things that we answered for for letter E for magnesium. So find magnesium on your periodic table. Everybody got it? All right. What period is magnesium in? 3. What sublevel? S. What group number? What are they called?
Earth metals.
Good. Okay. Alkali earth metals. Okay, one last question. You ready? Does fluorine become an anion or a cation? Anion. Does magnesium become an anion or a cation? Good. Awesome. Nice work. Okay. So are there any questions on chapter 1 stuff? Unit 1. I said chapter 1. Unit 1 stuff. We're all good? Okay, moving on. So significant figures. What I recommend is you guys actually have a spot on the back of this page. So yeah, so it's kind of, if you turn it over, we'll write down the rules and then I'll leave the rules up while you guys answer the questions. But it's kind of like right there on the back side. So just give yourself a little square. Okay, so I'm going to give myself a little square right here. This is where it is on your page. Okay? All right, so we're going to write our Sigfig rules real quick to make sure we've got it. Okay? So Sigfigs. First, you got to know how to count them. Which ones count all the time?
All non-zero numbers.
Good. All non-zeros. Okay? And then when we get to zeros, which ones never count? Leading zeros don't.
Trailing zeros if there's no decimal.
Hold on. Leading zeros, never. Okay. Trailing zeros, count with a decimal. If the decimal's behind it, then there's a decimal. So it counts. Okay? And then sandwich ones always count. Okay? All right, you guys should have what?
I thought like there's a decimal and then a 0 on the right.
Okay, so last little thing that you guys are going to write is plus minus or multiply divide. All right? So we know that the rule is all based around the lowest. But when you are adding and subtracting, should you be counting? Everyone, what should you count? Decimal places. Okay. My handwriting stinks today. All right, decimal places, and then multiplying and dividing is you count up your sigfigs and you use the lowest number. Okay? All right, so flip your page back over. I will leave my rules up here. I want you to do number 5 and 6 on the other side. Okay, so I'm going to turn on the lights again. All right, so the answers are as follows. So over here on number 5, okay, you should have had 3, 1, 3, 5. 3, 1, 3, 5. Are there any questions? All good. Sweet. Okay. Over here, 21.7 and 99.0. Okay. I made sure I gave you a 9 one, because those always bother people. Okay. All right. So this one you're counting decimal places. The other one you're counting sigfigs. Okay. So if we're all good, go ahead and flip your page back over so I know you're ready to move on. And we'll just kind of finish up this video and we'll start another one. Okay, so up here, you most likely will not have one like 7, but it's still good to be prepared. So what step would you start with? Parentheses. All right, so when we add 4.0 plus 6.311, whatever, you get what? You get 10 point... All right, so for this one, what are we counting? Decimal places. How many should I have? 1 decimal place. Good. All right, so you should get 10.3. Okay? Then from there, we had the 2.350 times 10.3, right? And so here we're counting sigfigs. How many should I end with? 3. Okay, so when you multiply them together, you should be getting 24.2. Oh, yeah, just kidding. That's multiple choice. All right, so you're just finding the answer with 3 sigfigs. My bad. Okay, so you should have gotten 24.2, 3 sigfigs. Okay? All right, and then number 8 over here. This is just a density question. So for density, remember your formula is D equals M over V. Okay. Your guys' lab, you used water displacement, right, to figure out the volume. Sorry, I'll rewrite it. Okay. Whoops. All right. But you use water displacement to find your volume. So you basically had a cylinder of water, you added something in there, the water level rose. You just want to know what that difference was, right? So in here it says a metal sample weighs this much. It was added to a graduated cylinder. This was the initial value. This is what it raised up to, okay? What is its density? So first we need to solve for volume, and we're going to do that by 24.85 minus 23.26. How many decimal places should I end with? 2 decimal places. Good. Okay. So volume ends up being 1.59. Good. Okay. And now we're just going to plug into the density formula. So we're going to have density is equal to 30.9232 divided by 1.59. And it's division, so what do we care about here? Sigfigs. All right, good. So we're going to go to how many sigfigs? 3 sigfigs. So your answer should have been... You guys type it in? 19.4 grams per milliliter. Okay? All right. Sorry, not 119. There you go. All right. Are there any questions on density? Awesome. Okay.